Okay, good evening. Welcome to
FamilyMath number 381.
FamilyMath 381. 381. 481.
481.
Yeah, sorry. 481. Alright, so you just watched the second video in this series that this woman, Kelsey Houston Edwards, who's a PhD student at Cornell, is making. And these videos are, I think they're really cool. What did you think of this second video?
Pretty interesting.
Alright, let's talk about, like, say 2 or 3 things that you thought were interesting. So what's one thing you thought was interesting?
Well, that numbers might not even exist.
Ah, okay. So, right. So question 1 was, do numbers exist? Sorry. What do you think?
Well, I mean, if no one was around to think about them, like, how could they... They're not real. Like, they're not real, like, that you can see or hear, feel or taste or anything.
Okay.
But if there's no one around to think about them, then I guess they could cease to exist.
Well, do you think numbers are real?
I think they're real, but they depend on having something able to think about them.
Interesting. Okay. All right. So that's neat. What's next? What was something else you thought was interesting?
The Goldbach conjecture.
Okay. And what did that say?
That said, for every even number, not including 2, it can be written as the sum of 2 primes.
Okay. So, for example, 10 is...
3 plus 7.
All right. I'll give you a challenge. I don't know if this is hard or not hard. 100. 2 primes.
3 and 97.
Okay. How about 60? Since it can't be 3 and 57. Why not? Why isn't it 3 and 57?
Because 57 is not prime.
How do you know?
Because it's divisible by 3.
Okay.
How about 53 and 7?
Alright, 53 and 7.
So.
Alright, so what does this conjecture say?
So, it says that all even numbers, except for 2, can be written as the sum of 2 not necessarily distinct primes.
Yeah.
And no one's been able to prove it. They said they checked numbers up to like 4 octillion.
Yeah, I didn't see what the number was, but it was some huge number beginning with 4. And she actually explained why this is a surprising conjecture. Did you catch that?
Well, because she said that primes normally have to do with like multiplying and dividing.
Yeah.
But explain what happens when you add them.
Yeah. So it's interesting. It's surprising how just the simple idea of adding primes together creates huge problems. Like addition's actually really mysterious when it comes to primes. And we've seen a couple of things in the past actually that related addition and multiplication that were very difficult to solve. Do you remember? There's one called the Collatz conjecture, for example.
Oh yeah, you take a number, I think if it's even, you add 3 to it. Or if it's even, you square it.
You divide it by 2.
Oh. So even you divide it by 2, if it's odd, you add 3.
You multiply by 3 and add 1.
Oh.
So that's the Collatz conjecture, and then it always goes to 1, but much like the Goldbach conjecture, nobody knows. All right, and how about a third thing that you found in here that was in this video that was interesting? Sorry, I didn't grab an eraser, so I'll have to squeeze number 3 in over here.
So, like there is not perfect shapes.
Ah, interesting. Okay, so she gave an example of a circle. And what was she talking about here?
So she was talking about pi. Pi it's infinitely precise, so it's for a perfect circle.
Okay.
But like something like this bottle cap.
Oh, that's lucky.
This
we have that on the table.
a perfect, like this bottom circle isn't a perfect circle, it has some flaw.
Okay.
So it wouldn't, like if we said that the radius of this circle was 1, the ratio of the circumference to the diameter would not be exactly pi.
Yeah, and it might not even actually be a perfect circle. Do you know how to define a circle?
It's a set of points that's a fixed distance away from one point.
Okay, good. Good. And then can you think of another shape that you've studied where objects in reality are probably not exactly as perfect as the shape you've studied?
Like pretty much any regular shape. Like maybe a sphere, for instance.
Okay. Yeah, a sphere, like a ball that you play with,
Yep.
might not actually be a perfect sphere.
Like it's probably not a perfect sphere.
Yeah. What do you think? What do you think, for example, about the Earth? Do you think the Earth is a perfect sphere?
No, it's more like oval shaped.
Okay. Yeah, it's pretty neat. This is a neat video, talking a little bit about some philosophy of math. Anyway, it's really cool. Good job, man.